Hello friends, welcome to my channel Easy Education. Be smart and fresh. Let us start here the today's subject. I am sure you must have heard the famous crow and jug story. It goes something like this. Once there was a thirsty crow, but the water in the jug was low at the bottom. The crow dropped pebbles into the water and the water rose up to the top. And the crow drank the water and it was no more thirsty. This is an example of Archimedes discovery and this discovery regarding water displacement. It is going to be the topic of this video. In this video, we will be talking about the Archimedes principle. And then we will do top 3 questions on this topic. In the next video, our focus is going to be on Archimedes principle. So you can watch that video after this. I will be putting the link in description below. And once you watch the video, your concept will be crystal clear to you. Let us start Archimedes volume discovery. Now, as the legend goes, Archimedes discovered this while he was taking his bath. So, as he was entering into that bathtub, he saw the water was overflowing. Then he had a miracle moment. He discovered that the volume of the water displaced by the body is equal to the volume of the submerged of the body. He loudly arose, "Eureka! Eureka! I found! So, if the entire body is under the water, then the volume of the water displaced is the volume of the water by the body. And the crow used this concept in crow and jug story to push displaced water up. So, there the volume of the water displaced is equal to the volume of the pebbles. Let us understand this concept with the help of some experiments. I am going to lower this ball into the beaker full of water like this. And as expected, you saw the water overflowed here into the bowl. Now, why is it that? Why the water is overflowing? It is because the ball is squeezing the water out. There is no more space, right? But it is hard to measure the volume displaced accurately. Because as you can see, all water did not go into the bowl here. Somewhat still sticking into the beaker. Some water is wasted here. So let us try this experiment differently. Now I am going to pour this water into the smaller beaker so that the water overflowed into the smaller beaker can be measured. So let us go ahead and see one more time. So I am going to lower the ball again. So as you can see, this ball has displaced the water into the smaller beaker. Now, what is the volume of the water displaced? It is 200 ml or 200 cubic centimeter of the water. So, by Archimedes' first discovery, the volume of this ball is the volume of water displaced, which is 200 cubic centimeter. Now, how we can verify that? So, we know that the ball is sphere. Here we know that the ball is sphere. Now what is the formula of the volume of the sphere? It is volume of sphere is equal to 4 by 3 into pi into r cube, where r is the radius of the sphere. So actually go ahead and check that with the help of the vernier caliper. So I have measured the diameter of this ball here like this, and the diameter of the ball is 7.2 centimeter. So the radius is 3.6 centimeter. Therefore, sphere volume is equal to 4 by 3 into pi into r cube. I am getting the exact value 195.5108571 cubic centimeter. Rahul is asking the query, why the beaker reading is 200 cubic centimeter? And as per the calculations, the answer is 195.5108571 cubic centimeter. By our previous experiment, we have got the volume 200 cubic centimeter. The difference is because the least count of the beaker is too much larger. Hence, we can't measure it so accurately with the beaker as mathematical calculations. Also, pi is the mathematical expression whose approximate value is 3.1415935 dash dash. The given value of pi is expressed in decimal, which is non-terminating and non-repeating. As the value is non-terminating, it shows the nature of irrational numbers. Hence, pi is not a rational number. Hence, this much error, say difference is bound to be seen. It is the limitation of the least count of the beaker. Least count is the capacity of the measuring instrument to measure the lowest reading accurately. The basic cause of this error is very important statement. Listen it carefully. Any two things in this universe are not identical, and even though they are identical, one cannot measure it accurately due to the human inability or measuring instrument inability. Hence, tolerances, that is upper limit and the lower limit of the dimensions, are given. The second reason is the parallax error that may occur while taking the reading of the beaker. So, for this reason also, there may be the difference. Parallax error is, while taking the reading, focus your eyes must be parallel to the reading line. If it is not, error is bound to occur. If you are looking from somewhat higher level, not parallel to the reading line, the reading might be lesser than the actual. Similarly, if you are looking from somewhat lower level, not parallel to the reading line, the reading might be higher than the actual reading. It is the human error while taking the reading. Man to man, there may be reading error. Hence, tolerances are given in the engineering drawing. So be careful. While recording the reading of any measuring instrument, say vernier caliper, micrometer, etc., accuracy also depends on the selection of the proper type of measuring instrument, having proper list count. Say whether the micrometer is of 10 micron list count or 1 micron list count. And what you want to measure, either road length or the machine surface like the thread of the screw. So take care. Keep your eyes parallel to the reading line. Don't see it from right or left sideways, lower side or from upper side. This is the parallax error. So don't worry. Remember, it is not the failure of the Archimedes principle. Archimedes discovery is correct. So the volume of the water displaced by this ball is the volume of the ball itself. John is asking, is Archimedes principle holds perfectly for having different density? Yes, it holds. Density is inversely proportionate to the volume. Density is equal to mass divided by volume. By keeping the mass constant and by changing the different types of density, the volume of the liquid displaced by the body will be different. By keeping the mass constant and by changing the different types of density, the volume of the liquid displaced by the body will be different, keeping the different level of floating height. Rubber cube will not displace more fluid and float at higher level compared with the wooden cube or steel cube. The best example is ice floats in the water because its density is low than the density of the water. Archimedes' discovery is correct. So the volume of the water displaced by this ball is the volume of the ball itself. We can actually find the volume of the ball in an easier way by measuring the rise of the water level. So as you can see, the initial rise of the water level here is 600 cubic centimeter. So I am going to lower this ball one more time and keep an eye on the level of the water. As you can see, the level of the water is raised to level as 800 cubic centimeter. The difference in the volume of the water is the volume of the ball, which is volume of water is equal to 800 cubic centimeter minus 600 cubic centimeter. That is equal to 200 cubic centimeter. It shows the volume of the ball. So the displaced volume, that is basically the volume that rises or that is overflowed of the water. This discovery is very useful for measuring the volume of the irregular solids. Archimedes used this to measure the volume of the king's crown. But I don't have that crown. I use this odd-shaped toy instead of the crown to measure the volume like this. So the toy doesn't have the regular shape. I can't use the formula of volume like length into breadth into height or that of the sphere. So what I am going to do? I am going to lower the toy into the beaker of the water like this. So let us go ahead and try now. What is the initial volume of the water here? As you can see, 150 cubic centimeter. Now I am lowering the toy into this beaker. As you can see, the water level has gone up to 175 cubic centimeter. So what is the volume of the toy? That is 175 minus 150 cubic centimeter. That is 25 cubic centimeter. So the toy has the volume of 25 cubic centimeter. Let us place Archimedes Discovery on our concept board. When the body is completely immersed in the liquid, so we can say the volume displaced by the body is equal to the volume of the water displaced. Now, let us check the partially immersed body. So, what are some examples of the object that are partially immersed in water? Example is the floating ball like this. As you can see, it is partially immersed in water. Or an iceberg is an example of the partially immersed in water. Let us take out this ball. And if you put your hand in water like this, so you can see your hand will be partially immersed in water. So let us understand the partially immersed case with the help of the experiment. So with the help of this string, I am going to immerse partially this ball into the beaker of water here. But first, check what is the initial volume of the water. As you can see, it is 600 cubic centimeter. So I am going to lower this ball so that it is partially immersed in water. What is the volume of the water now? As you can see, it is 700 cubic centimeter. So how much water is being displaced? It is 700 minus 600 cubic centimeter. That is 100 cubic centimeter of water displaced. What is the volume of the ball which is under the water? That is right. It is 100 cubic centimeter. The volume of the water is this. This was our partially immersed case. Let us partially immersed case on our concept board. For the partially immersed case, the volume of the liquid displaced is equal to the volume of the partially submerged part of the body. Now we have done the Archimedes discovery. So are you ready to move on top 3 questions on this topic? Here are the top 3 questions. I encourage you to pause here and try to solve these questions. I will be posting the video on the solutions soon. I hope the Archimedes discovery is very clear to you now. So next time when you put your hands in water, you see the water level is rising. I want you to remember Archimedes volume discovery all. Be prepared for both power and courage to do anything. Get energy in your body and mind. Please like it, share it and subscribe it. Thanks for watching.